All right, thank you very much. All right, I know it's just a 15-minute session, but promising you it's not just slides. There's going to be some interesting material in the next 5 minutes, okay? Less than 5 minutes, so bear with me. So yes, I'm going to be talking about how, from a StreamSets side, we're going to be powering, rather making your Delta Lakes way more productive in how they can be powered by enabling sort of streaming data coming into your Delta Lakes. Myself, Rupal, I've been at StreamSets now for over 3.5 years. I've been in multiple roles, from doing pre-sales work to partner engineering work, a lot of focus on partner engineering. And now I'm also focusing on a lot of our cloud services, whatever they're tied to, different cloud platforms, different cloud vendors, things like that. I work closely with Databricks, hence the Delta Lake part with StreamSets integration is definitely one of my focus. So, not going to go into details about this. You all know that it's typically a common pattern that users who've already built data lakes, I wouldn't say Delta Lakes, data lakes today with existing platforms like whether it's Hadoop, whether it's on the cloud using cloud vendor storages like ADLS, Google, S3. I have worked with a lot of customers also. There's always a challenge in how to get streaming data into your data lakes. How do you design your data lakes? How do you make sure that data can be updated, I guess, in your data lake? What are the best practices to get your data into your data lake? What formats to use? How frequent do you get it? What is the SLA you bounded with? How do I make sure it's the right data you get? There's so many different challenges you get. And the most common questions I've gotten so far in the last 3-4 years from customers who deployed their data lakes on whether it's Hadoop or other platforms, they typically start pushing data into HDFS, use Hive for querying, and then the next question comes. Okay, I have data. This is my new data lake. How do I start updating my data in Hive? Because I need that as my transactional, base, I guess. So there's a lot of back and forth. You have to try and make people understand how that actually doesn't work, right? You have to think about all the architectural things around it. So the things that you must make sure when you build data lakes are, of course, data integrity. How do you make sure the right data is coming at the right time, but in the right sort of data that you expect? There's no quality that is being malformed. The second thing is infrastructure. How does the infrastructure handle all the data that you're going to get, whether it's batch, whether it's streaming, whether it's unstructured, binary, whatever have you, okay? Infrastructure must handle that. The second part is how does it automatically give you the right query expected at the right time? You don't have to worry about the query to collate all your data, pull up large data files for you before you can start running your query. Making sure the performance of a query you're running is irrespective of how data engineers have landed data. How do you make that autonomous, right? And then the last piece definitely is cost. Cost effective, whether it's people cost, whether it's all of these tied together, making sure your cost is reduced. So that's where Delta Lake comes in. I've played around with Delta Lake compared to all the different data lake frameworks there are. It definitely solves a lot of different things. It takes care of handling small file problems. Who cares about small files now? Just run one command, Delta Lake will handle it. Query performance, don't worry about how it's querying. It's going to automatically handle your partitioning predicates, run your queries based on what it's best and good at. And best on a columnar format, it gives you ACID compliance. That's the beauty of Delta Lake, apart from so many other things. But from a StreamSets side, what we've done and made easier is working with Delta Lake, not just from a batch standpoint with typical Delta Lake and data lakes. We also enable now streaming data coming into it in a streaming fashion. So I'll show you how that works. Bear with me. Now, spoken about data Delta Lakes, but what is StreamSets? If you're all new to StreamSets, so StreamSets is a platform where we automate a lot of we enable a process, basically. It's not just doing data movement, but it's the entire process of How do you ensure your design process for getting data into a data lake, a Delta Lake, or out of Delta Lake, but at the same time handling any kind of data that's coming in terms of design is automated. It's deployed in an autonomous way, in a continuous way, and operated in a continuous way. And what I mean by that is, don't worry about manual processes where you have to go to someone, orchestrate it. Hey, have you done your piece? Have you moved it to production? Checking. Forget that. Make it all automated. So that's where the StreamSets platform comes into play. Automation is the biggest piece. So as a platform, we give you a single sort of design tool for handling all your data movements. It handles the deployment lifecycle, CI/CD, making sure you also have data in the right SLAs provided, and then operate. So continuous operations. Now, when it comes to the end-to-end, sorry, let me go back. Okay. When it comes to the actual platform and what it constitutes of, there is the left side that you see. So you have multiple data sources. Data sources could be coming from traditional data files, databases. It could be coming from databases in different formats, meaning incremental that you want to pull based on primary keys that are being changed or updated, or change data capture for that matter from databases. Or you go into applications like Salesforce, other CRMs, you can capture data from there. Or it's IoT sort of data that's coming all the way from your devices. All of that can be handled with the ingest piece from StreamSets side. Once you've ingested, you'll definitely land it into a specific data store. You can choose what data store it is. We handle all of those, give you a platform for that. Now, in this case, the example shows you how you're building a Delta Lake, sort of lake where you land your data, then you sort of enrich it or just massage it a little bit, make it consumption ready, move it to your curated zone, after which you want to move it to actual consumer ready format. All of that can be done with what we call as the StreamSets transformer plugged in. So there are different engines that allow you to do ingest all the way to transform with the StreamSets platform, okay? So the deployment of all the components on StreamSets, we have a way to automatically use a PaaS service, a SaaS service rather, on cloud, or you can deploy it on your on-premise infrastructure if you want, and you can deploy it anywhere, whether it's your on-premise systems directly, on cloud if you want to scale with Kubernetes. All of that is possible with StreamSets. So I'll jump into demo. So what I'm going to do is, there are actually two demos. One showing how we handle change data capture with Delta Lake. Now, if you're familiar with Delta Lake just a month ago released new features where it allows you to do merge statements, which allows you to do not just inserts, but updates and deletes. So it handles the end-to-end transactional consistency with data that's coming in. So that fits really well with data that's coming in from a change data capture enabled database, which gives you, again, transactional operations which are coming in. So I'll show you how we capture those and how we also automatically replicate it into Delta Lake. Okay, so what I have running here, before I run it, I'm going to show you. This is our platform. It's called Control Hub on the top, but it gives you full visibility of what's happening across your entire StreamSets platform. There are pipelines. Pipelines are basically, you get data coming in, we do some transformations, push it out. That's a pipeline. Pipelines can be version controlled. You can have pipelines running on what's called a data collector, which just pulls data, does some massaging, pushes out, or transformer, meaning it's a Spark-based engine, so it can run on Databricks. So you have pipelines irrespective of which engine it's running on, but irrespective of how it's being done, we provide you that full, what we call as topology. So topology in our world is, let's say, in my case, for my CDC, I have this topology. So I'm getting data from MySQL CDC, after which I push it to Kafka. And then I'll run this pipeline, which is going to be taking from Kafka and pushing into Delta Lake. So let me just start this up again. But while it's starting, on my CDC pipeline, it's going to look like this. So I get data from my SQL, and I have a CDC origin. Then based on the operation type, what I'm going to do is, if it's a delete operation, I'm only going to keep the primary key, because for Delta Lake, I only need the primary key. But if it's inserts and updates, I'm going to keep the entire record, after which I push it to Kafka. After that, the Delta Lake I'll show you what it does. So I'll start running the full topology. Give me a second on this. This is basically the pipeline that's going to run, push to Delta Lake in this case. So let me just change this to the latest. In Delta Lake, again, it's a config-driven GUI, right? We have a Delta Lake destination. In here, the user will choose how they want to write into Delta Lake. You can just choose to sort of append data continuously to Delta Lake, or use these constructs to say upsert, so insert or update based on the operation you're getting, or just delete or only update. It depends on however you want to do it. So it's pretty flexible on how you want to build your specific storage in Delta Lake. So I'm keeping it as upsert. So anytime I get inserts or updates coming in, it's going to check the primary key that's coming in and automatically update and insert based on a match or not match. Okay? So I will run this pipeline. Just give me a sec. So just update the version, because I changed my Kafka topic to read from the latest only. Okay. Anyway, all right, so once this starts, essentially we're going to see this pipeline running. I'm going to just start it manually. But for some reason, it's running, but it's not showing it's running. So it shows it's running. All right, I'll let it be. Sorry about this. It's just some okay, let me just run it from here. So I have my pipeline for Delta Lake. I'll just run it from here. So what it's going to do, it's going to start running on Databricks. And essentially with Databricks, we can state inside StreamSets whether we want to create a new cluster or use an existing cluster. So you can provision a cluster on Databricks, choose the explicit configs Databricks provides, or use existing. Right now I'm just using an existing cluster. So it's going to push out this pipeline to run on that Databricks cluster. So once it's started up, you'll see the job metrics here. So this is where it's running. All the specific runtime that's happening is happening on Databricks side. There's nothing happening on the StreamSets side. StreamSets is only instrumenting that specific job. So you can see all the logs here for that specific job. If there are errors happening, you'll see them here. So right now it's just starting. So it's just started, yeah. All right, so what I'll do now is I have no data in my table. I've just made sure I'm using the customers table. And what I'll do here is, let's start pushing some data into my MySQL table. So right now, when I do a select star, there's no data here. So I'll go and insert, let's say 1 record for now. Got 1 record inserted. We have one customer name Renoir and details about it. So if I go back to the StreamSet side, it automatically picked it up, pushed to Delta Lake. And I will, okay, it wasn't empty, but assume it was empty. We know what the name is. Renoir should come in. Okay, it's repeated twice, but don't worry. So we have Renoir, that's coming in. That's one insert. Let's go and add maybe a couple more. So another insert, this time Cezanne. And we'll see the pipeline getting updated with 2 counts, pushing to Delta Lake. Now remember, with Delta Lake, you typically want large batches. Right now, just for demo, I'm showing you one by one, so you actually understand how it's replicating the actual transactions going in. So let's do a star again. And you have Cezanne that came in with 2 and insert operation. So it's pretty straightforward, nothing magic here, right? Now let's go and update. Let's say I added Cezanne. I'll probably update the address for Cezanne. So I'll do an update statement for that. I'll say, let's set the address to Downing Street, okay, where customer ID is 2. So it's going to update it. You'll see that the table here is updated. Okay, so we should expect the same data from our table here. And that got updated. So that's it. I didn't write any code. It's just the StreamSets config that's saying insert or update, and boom, Delta Lake is updated on the fly. Same thing can be done for delete. Delete, it just matches the ID, customer ID, and it'll delete the row in Delta Lake. Okay. Let's hold on questions just because of time. I'll finish the second demo, and then we can take questions after that. All right, so for the second demo, CDC works fine if you're only dealing with pure replication with tables. Now this can be done with not just one, it can be done with a full schema. It doesn't matter. StreamSets handles that on the fly. You don't have to explicitly code and hard code the table names. Now when it comes to replication, the next typical DBA's perspective is rather than automatically updating Delta Lake, keep audit history. And that goes into the next demo, which is going to be about how do you handle what's called slowly changing dimension. All of you familiar with SCD, slowly changing dimension? All right. So SCD type 1, it only keeps the latest data, which is almost like this, but we're not going to do that. I want to show you how we handle SCD type 2, which is where we capture all the audit history of what has happened in the transactional data set, okay? So for this, I have another table called SCD, and no data right now, but I have a separate pipeline. For that pipeline, it looks like this. I get data again from Kafka, And we have what's called a slowly changing dimension processor. What this does is it automatically matches data that's coming in. You can choose what type you want to do SED for. And then you can also choose what to match for SED. So you have to provide what keys you want to identify, whether it's insert, update, or not, right? But you can also automatically choose what kind of parameters you're using to denote your type 2. It could be version, it could be active flags, it could be, end and start, date, timestamp. So all of you familiar with data warehousing constructs, this is common. So in this case, I'm only using version to keep it simple, but this processor will automatically calculate incoming records to identify whether it's a net new record, meaning version 1, or it's additional, so it needs to increment the version number. So it'll take care of this on the fly, right? So I'll start running this. Now in this case, what I'm doing is, to keep it simple, rather than using MySQL, I'm going to simulate data to show you how you can, again, use StreamSets to test and debug on your side, right? So it's going to read from Kafka with a topic name of SED1. And I have another pipeline that's going to feed that topic, so SED1. What I'm doing in this case, one second. Okay, so for this, I'm going to push data to, forgive me, my Kafka topics config changed. Okay. All right. So I'm going to generate some data, and what I'm doing, I'm simulating some CSV data. So, I have customer ID 1, 2 with this data set. So the first time it goes into Kafka, given this is net new data in Delta Lake, this pipeline here is just going to insert that data into Delta Lake with a specific version number. So I'll start running this. So we have 2. And on this side, I'll pick up those 2 records. So it's picked up 2. It's doing the SED and pushing to Delta Lake. And if I go back to this now, so it's inserted, but it's also inserted a version column here, which wasn't there before. Now, what I'll do is, again, because I'm simulating data, I'm just going to change the raw data to insert now, also update something else. Already have some data, I'm just going to copy. So let's say I am going to add 1 in, let's say, not this, sorry. I'm going to update 2, and I'm going to add a 3. So I'm adding a column, but I'm also updating the same data. Harry Potter now is living at number 12, blah, 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 okay? So I do a start pipeline again. Great, there's an error. You see how errors are being generated. But okay, right, there you go. Thank you. Okay. Okay, so 2 records added. We should see 4 coming in here. So it picks up 4, it's writing to Delta Lake, and I'll just query this table now. Right, so you see now 2 was an update, but the version has incremented automatically. So anytime you do updates to the same records, the type 2 for SCD will automatically handle your flags, whether it's your version number in this case, active flag, end or start timestamp. Cool. That's it. So just quick takeaways, no code, but it handles all your streaming data, wherever it's coming from, automatically with Delta Lake, whether it's pure transactions or with SCD that you need. Any kind of transformation logic is handled with Spark underneath, with Transformer, with StreamSet side, and you get that end-to-end visibility of how your data is moving in. So just for next steps, if you do want more information, more demos, we have a booth 88, so you can come by there. But I'll be outside after this. So yeah, thanks.
Right. Thanks, Rupal.
Thanks.
And please don't forget to visit the StreamSets booth if you have more questions. We are doing a little bit over time, so we cannot take questions here, but please feel free to see these guys.
Yep, thank you.